welcome to the second day of the Technology in Maritime Global Virtual Conference 2021. We are extremely happy to welcome all our delegates, all our visitors, and all our speakers and guests who are watching us in our live today from the platform, as well as through our Naval Connection live Facebook and YouTube channels. We had a tremendously gallant and marvelous day yesterday, filled with choicest of speakers coming and sharing their views and experiences with all of you, and very engaging sessions. I will be going into a recap soon. But before that, I want to again wish you a very good morning and afternoon, a very good evening, and after this session, a very good night. Of course, starting from wherever you are right now, we have so many time zones watching us from across the world. We thank you all for your engagement with the Naval Connection virtual events, and you've been engaging with us throughout, even after the event. I was flooded with calls and WhatsApp messages from all across the world stating how wonderful and of a learning experience this has been. So thank you for your engagement on the second day of TIM. We have a glorious day ahead. And starting on what we did yesterday, yes, yesterday was our first day where we started off with the inaugural session, which hosted a lot of dignitaries from the administration and two consul generals, Consul General of Norway, Consul Generals of the Netherlands, as well as the Vice Chancellor of Indian Maritime University. And we had Eero Letovara and coming from Finland, talking to us about autonomous ships. Then we had Gillian Carson, who's the president of the Nautical Institute, who came and spoke about risk assessment. And we had Gordon Meadow, who came and spoke from UK about marine robotics. We had Anne Till also from the UK on she gave us a splendid presentation on remote operation of subsea vessels. We had Levitsen from Turkey, who had from UK, sorry, and from Orca, and who spoke on remote ship inspections and connectivity. Satish Kanakasabai from Terromarine, a part of the Ocean Technology Group, he came and spoke about how can we ensure the promise of big data delivery to ship operators. And lastly, for the last session yesterday, we have Arild Sale, the Chief Executive Officer of ScanReach, and he gave us a splendid presentation on wireless connectivity on ships and search and rescue operations. So we are all set for today, and a splendid session ahead. We will request all of you to take the maximum out of this splendid platform that we have built for networking. There is a networking lounge where you can meet up with people. Between sessions, you will see a networking sessions each where you can just go and meet new people and talk about your business and increase your business reach, which will in turn increase your business profitability. We'll strongly recommend you also to visit the exhibition arena where we have all the 3D booths which are set up. We have Vatsila, we have HIMT, we have Storms Geo, we have Bloom's Energy, we have Ocean Technologies booth, and we have ScanReach. Please do visit. We also strongly suggest all seafarers to go and visit the HSBC booth. The HSBC has launched a special dedicated mariners account, and all sailors who've been watching us, please go and visit the HSBC booth and to know more about the splendid HSBC mariners account. This program is being brought to you in association with HSBC, and the industry partners has been Indian Chamber of International Business. We have also been supported by the Nautical Institute and the full maritime media. So we would like to take this opportunity to thank the maritime media, Marix, Bhandarkar Publications, Port to Port Sagar Sandesh, and our in-house magazine Sea Link, which is India's one and only, in fact, it's maritime industry's one and only audio-visual magazine. So as you flip through the pages of the Sea Link, you can click on anywhere, you can increase your business reach, we can program your business to be your videos itself also on the pages. So it's India's first, and maritime industry's also first, audio-visual magazine. So yeah, so it's time now to introduce our speaker of the day. The session session number 8, is it? We've already covered 7 sessions yesterday. Yeah. Session 8 starting today, first session. Welcome to none other than Mr. Suminder Singh, who's joining us right from US. It's almost close to midnight there. I think it's 10:30 if I'm not mistaken. Yeah. And he's joining us from California. Suminder Singh is the senior director of Bloom Energy USA. Suminder has more than 25 years of experience in critical power infrastructure in large organizations as well as startups. Prior to leading Bloom Energy's efforts in commercializing solid oxide fuel cell technology, I mean, that's something very technical, right? We're going to ask him about this solid oxide fuel cell technology. And that Bloom Technologies and Bloom Energy commercialized and for the maritime for marine applications. Suminder led site designs, permitting, and utilities team. Under his leadership, Bloom Energy increased power generation capacity from 200 megawatts to over 500 megawatts. During Suminder's work experience at APC, he was instrumental in launching a new product line, which grew into a 500 million business unit. Wow. Suminder has bachelor's in electrical engineering from University of Wisconsin, Madison, and master's in business administration from University of Chicago, Booth. So welcome, Mr. Suminder Singh.
Thank you.
From
Thank you.
USA Bloom Energy, and he will be speaking to us on the next 20 minutes, and then we hopefully will have questions to ask him, and then have a 5 minutes one-on-one chat with Suminder. Suminder, welcome to the Technology in Maritime 2021 in maritime industry's largest platform and largest virtual global conference on technology. Welcome.
Thank you, sir. Thank you very much.
Over to you.
Can you see my screen?
Yes, we can. Please go ahead.
All right, so I'm going to try to wrap up this presentation in 20 minutes. My goal is to talk about solid oxide fuel cells as an alternative means of power generation in marine world. So Bloom Energy was initially formed in 2001 by Dr. K.R. Sridhar. Dr. Sridhar was a professor at University of Arizona, and at the same time, he was also working with NASA, where the idea of bringing fuel cell for power generation came along. Since 2001, the company has gone public. It's listed in NASDAQ, and we have deployed more than 500 megawatts worth of power generation all over the world. And the technology has demonstrated its ability to scale as we continue to deploy this technology in countries such as Korea, India, Japan, other than the US. Solid oxide fuel cell, by its inherent nature, is a fuel flexible technology, and I will go over that. It can run on methane, it can run on a combination of methane and hydrogen. That gives the marine sector a new technology as it's ramping up to deal with international marine organizations' emissions requirement. So at a high level, as I briefly mentioned, we have been deploying this technology for a land-based application. And now since last year, we started the process of hardening or marinizing this technology. Right now in Southern California, where we are testing the system for its 22.5-degree tilt test with vibration testing also going on with the intent of making sure that the technology is mature enough for deploying in the marine environment. We have also engaged ABS for the type certification process, and we have also identified beta customer sites where we'll start deploying this technology in 2022. So what is a fuel cell? Well, there are 4 different types of fuel cells, and I won't get into what the mechanism of different fuel cells are. But effectively, what I'm going to be talking about is solid oxide fuel cell. It's a very high temperature fuel cell. It runs at 800 degrees C. And by its inherent nature, the solid oxide fuel cell tends to be the most efficient of fuel cell technologies that are available in the market. The fuel that it runs on is methane, or a combination of methane and hydrogen. And effectively, what this technology is, there is an electrolyte membrane, and on one side we coat it with cathode ink, on the other side we can coat it with anode ink. We pass hydrogen-rich fuel on one side, which has gone through the reformation process, so the hydrogen becomes loose. And on the cathode side, we are passing ambient air, which is rich in oxygen. The oxygen, which is rich in the air that is rich in oxygen, it crosses over the electrolyte membrane, thereby generating electricity or electrons. So these electrolyte ceramic membrane is sandwiched between two metallic plates, and these metallic plates become the conducting material. And then we stack these cells just like any typical battery to form stacks, and these stacks then form columns, and the columns that we have are plus minus 400 DC output. The output from the stacks is unregulated DC, so we do have DC to DC converters, which regulates the DC output, and then we have inverters which convert the DC to DC output to AC output, and then we combine all of these as building blocks to form larger power plants. What you're seeing on the top right hand side is a 300 kilowatt building block, and what you will see on the bottom right hand side in the small circle is almost 30 megawatt plant, where we can parallel systems to scale up the system to a multi-megawatt power generation. So solid oxide fuel cells, or typically any fuel cells, they run on hydrogen. And hydrogen is going to be one of the key fuel for the future, where if you have to remove the greenhouse gas emissions, or get the greenhouse emissions under control, or even do the decarbonization, the hydrogen is going to be a key fuel for that play. However, the most important thing is going to be that the green hydrogen is going to be necessary for that. And green hydrogen comes from the electrolysis of water, where we use a renewable energy source such as solar or wind to produce hydrogen, and then that hydrogen is transported to various sources of consumption. The critical part is going to be that if you have to get the carbon emissions under control, we have to ensure that the green hydrogen becomes far more available all over the world. The issue is that right now, to get hydrogen accessible to various sources, we effectively need almost $5 trillion worth of infrastructure. So I think it's going to be a long-term play. I'm expecting between 2030 and 2015, where various companies and countries are going to start investing in this play. But for the short term, I envision that it's going to be a blend of methane or LNG that is going to be the interim solution to power the marine vessels. So what is the benefit of the solid oxide fuel cells to the marine world? Well, solid oxide fuel cell is a low carbon emission technology. It virtually has no NOx and SOx. There is negligible methane slip of this technology. And above and beyond that, the modular and scalable concept of the fuel cell technology allows people to arrange the systems in a more flexible manner. And last but not the least, the water requirement during the system operation is negligible. We only need water during the initial startup, but the net chemical process that the system utilizes is a net water producer. I again want to emphasize that fuel cell technology is not a combustion technology. It's an electrochemical process. Therefore, unlike the combustion engines, you do not see any carbon or particulate matters that come out of this technology. So I want to take a few minutes to talk about what experience Bloom brings to the table that will be valuable for the marine sector. First of all, I'm going to start with the microgrids. As some of you might be aware, in California, there is this, effectively there have been no rains for the last 3 years. The environment extremely dry, so it's very prone to fires. So a lot of utilities in California are implementing public safety power outages, which is an effective way to manage any fire risks from extremely dry vegetation. So under those environments, a lot of businesses, they don't want to shut down their operations. So they have been coming to Bloom Energy to deploy microgrids so that they can continue to operate their manufacturing plants, their grocery shops. So we have been deploying a lot of these microgrids. And I think this microgrid could also be critical and crucial for marine applications. We have deployed almost 115 microgrids since 2011. In one of the last microgrid event, we continue to keep a 4.3 megawatt site up and running for almost 5.5 days. And this was a critical manufacturing facility. And since 2018, we have protected Bloom customers from almost 1,750 power events in California alone. So another application of the fuel cell technology is community power. There are a lot of communities in America where they're starting to ask for cleaner energy generation technology, which is also price competitive with the grid. So we have deployed 7.5 megawatt power generation plant in New York City to meet the requirements of the neighborhood where they wanted cleaner fuel, which is also easy, which is also cheaper compared to the local utility. So the key over here for the community power is the community demands that they want cleaner, cheaper, more resilient energy. We go and find a place where we can install a system. It's typically close to a utility power station or a distribution substation. And then we tie our system into the substation, and all the electrons that are generated go through the power distribution network to the customers, which could be residential and small commercial customers. So this is what, for the lack of better terminology, is called community power. And I believe that some of these things can also be deployed in the marine world, especially in cruise liners, where if a customer is intending to reduce its carbon footprint, they can effectively deploy fuel cells to augment the power needs from combustion engines. There is also, we have also deployed a 6 megawatt power plant in New York, which was for the distributed power grid. So sometimes utility has this need where there is a mismatch between the supply of electricity and the demand of the electricity. And for the utility to meet the demand, sometimes they have to build more power generation plants and upgrade their power distribution network. Sometimes that's a very expensive process. So the utility in New York came to us and said they wanted to deploy 6 megawatt in a zone which was becoming a choke point for them, where we went and deployed a very compact multi-tower configuration of 6 megawatt power generation plant. So I envision some of these approaches can be valid even for cargo vessels or for LNG carriers, where if someone is interested in augmenting or offsetting some of their existing generation, we could provide containerized 1 megawatt power generation blocks that are built on a fuel cell technology, which will start to become available in 22 and 23 and beyond. So that's pretty much it from my side. That was my last slide. I want to give more opportunity to everyone to ask questions. Shaukat? Did I lose everyone?
Hello. Yes, Suminder.
Yes. So that was my brief presentation. I want to give more opportunity to people to ask questions.
Yeah. I was just waiting. I was just trying to. I was just absorbing all the things that's come in. It's quite a lot actually. If you see, there's a lot of information and a lot of technicalities, a lot of technology involved in what you said. Yeah. So Suminder, just as I wait for questions to come in from the platform, I would want to ask you something that was going on in my mind when you were speaking. I mean, like I said, there's lots and lots of new technology and very technical stuff that you showed in between the slides. But what kind of experience? What is your experience in deploying these, proven these kind of technology in the market?
Yeah, so most of the projects that Bloom has executed right now, they have been in kind of mission critical data center space and also hospital space, where a data center would come to us and say they would want to augment the power generation, or they would like to reduce the dependence on utility. So we do a baseload power generation, or even the hospital would come to us and say, we want to reduce the carbon emissions because we're a hospital, we want to be the thought leaders in critical infrastructure space, but also reduce our carbon emissions. And by the way, if we can save some money also, that'll be beneficial. So Bloom has done substantial amount of projects in that space, which is hospital, data centers, and also in mission critical microgrids.
Right, understand. And while you were talking, there were questions, 2 or 3 questions which will come in the platform. In fact, it's actually the similar kind of questions, exactly the same question which I had for you in my mind. And I had planned to ask you how Bloom Energy wants to bring this technology, has a vision of bringing this technology in the market. While I wanted to ask this, there's a seafarer who has asked you the same questions I see at a
Shaukat, I can't hear you. Shaukat, you broke up. I couldn't hear you.
Yes,
I lost a minute.
yes. So yeah, so let me rephrase this question once again. As I was wanting to ask you the plans of Bloom Energy to vision to bring the technology in the market, while I was wanting to ask you this, there's one seafarer who's asking you the same question, and he's put up that question live on the platform now. And he asks you, has Bloom Energy already started its projects on board ship?
Yeah, so right now where Bloom is, we are in the process of hardening our systems. So I'm in Southern California in Fullerton with a lab that has a test bed where we're doing vibration testing to make sure that the system can stand the vibrations and the tilt of the marine sector. We expect that our design will be completed by end of this year, and then our first system deployment, we're expecting it to happen by June of next year. And then we have additional customers that are lined up for further deployments towards the end of 22 and 23. So these are pilot deployments where we'll be demonstrating the functionality, the efficacy of the system. The commercially available systems should start becoming available 23, 24 and beyond.
Very good, thanks. And noted. There's another question which is come to you from another seafarer, and Anirban has asked the following questions. He asks if there is complete replacement of ICE with electrolysis technology, then what does it hold for mechanical background engineers or merchant navy engineers? Does this question make sense to you?
So can you elaborate on that? So is that more like, is this going to make the system completely obsolete,
Yeah,
or
I think
mechanical
he wants
engineering
to.
field?
Yeah, I think he wants to ask. What he wants to ask is, well, I just can you go up on the platform, please? I've changed the question. Yeah. So I think he wants to ask is that if there is a complete replacement of ice with the electrolysis, if there is a change, then what does it hold for? I mean, I think he wants to ask for the training and mechanical background engineers or merchant navy engineers. Would they need additional skills?
Yeah,
If
I mean,
I've
I'm
understood
sure
the
there
question.
will. Yeah, I think there will be additional skills that would be needed, because effectively, what you're talking about is the fuel flow. So there's fuel coming into the system. There are air blowers. There are some mechanical components that are part of the system. They will need preventative maintenance. Obviously they will break every now and then. They will need to be replaced. So there will be a whole training curriculum that Bloom will need to develop so that the engineers on the vessel can maintain the system. And that's one of the things through the pilot that we will be developing the training curriculum that we will need to train all the engineers on the vessel so that they can maintain the fleet of our system.
Fantastic. We are having a lot of engagement. Is another question, another two questions by the same person. So I'll just merge those two questions into one. I think we'll only have time for this question. Last question. Bala Subramaniam Ramaswamy asks, how much is the cost and space required if it is meant to be used at home? And what about maintenance requirements? Can it be done by self, or some technicians would be required?
Yeah, so this is not really a residential product. This is a larger commercial system. We're talking about megawatt worth of power generation capability. So it will definitely require skill set. Are you saying something, Shaukat?
No. Sorry, please go ahead. Yeah.
Yeah, so there will be training required. This is not something that someone can walk up from the street and start to maintain the system. In terms of comparison, right now, I think the power density of our technology is not really comparable with ICE. I think it's going to be probably 2x the size of the ICE engine. But I think over time, over the last 20 years, we have already increased the density of our system 7x times. So, and this technology is going to mature. It's going to become more and more compact over time. And we're not talking about 1 or 2 years. We're talking about 20, 30 years time span. The efficiency of the system is going to start to get even better. Right now, we are at 60% electrical efficiency without CHP. And I think that is going to get even better. So I think overall, the fuel cell technology, while it might have some limitations, but the fact is that this electrochemical process by far is the most efficient process by which fuel can be converted into electricity.
Very good. I don't want to let you go, but we have like a strict time compliance schedule because we have back to back. There's somebody else, Dr. Kwangal Lee, is waiting to be, again, he's in America joining us. But before I let you go, Suminder, there's again one very short words, and there's one more question which I want to throw at you, and it's come to us from the platform. Mr. Ajay Gautam has written, what will be the time for return on investment if it saves cost for, say, some industry, such as you said, hospital buildings?
Yeah, so all of that, so there's a lot of financial engineering that goes on in figuring out the ROI for the customers. I think for the marine sector, we will have to figure out the ROI. All I can say is that we have deployed 500 megawatt worth of power generation. It has made sense for the customers. That's why they have deployed it. We have a lot of repeat customers. That's Apple, Intel, some of the name brand customers who continue to come back to us. So the economics make sense for the land base. We have to go and figure out how to make the economics work for the marine world.
Okay, fantastic. Suminder, this is where we have to end. I mean, I can't keep on going on, although I want to stay and talk more with you. Viewers, thank you for your engagement. Lots of questions are coming in. You can connect with Bloom Energy in their booth. They've set up a fantastic booth in the 3D platform in the exhibition lounge. Please do visit. If you have any questions, write down in the chat box. You can go and actually meet them in a video conferencing or chat with them. And write to us at events@navalconnection.com with your questions. We will put those questions to Bloom. And this is actually the start of a very intense business relationship. It's not just one event, but the follow-ups that we do. Suminder, I can't thank you enough for spending time with us and engaging. Although it's not daylight hours there, you made time and spoke to us, and hundreds and thousands of people actually watched you live. And we will be coming out with a souvenir in the next 10 days, and which this session will be recorded and of course produced in our C-Link audiovisual event, audiovisual souvenir. So from Tim Conference, is a very thank you and namaskar. Stay well, stay happy, and stay safe.
Thank you, sir.